Hello learners, and welcome to a video tutorial about our activity for today, the video analysis of the marble block problem. So what we had was a marble coming in with an initial velocity v, hitting a block, and the block was just resting on a table, so it had a center of mass, and the marble bounced back and the block translated but rotated forward. Now, here was our problem for this. We wanted to figure out the moment of inertia of the block. And so we'd use conservation of angular momentum to do that. And so going into the collision, only the marble had angular momentum. So its moment of inertia was just r squared, r being distance from axis of rotation, times its angular velocity, which would have been v naught over r. Okay, now that would equal, well, after the collision, both objects have angular momentum. So that would be the moment of inertia of the ball again, mr squared, times, now it bounces back, so that would be negative v2 over r, plus the moment of inertia of the block times its angular velocity. Now, here's where a lot of confusion set in on my part also. I completely forgot that the block, wasn't anchored in at any position. It just translated and freely rotated this way, which means that the velocity here of this center of mass, that point that you tracked along, like a 3.26 meters per second or something like that, that particle has no angular velocity. So when we talk about things rolling without slipping, and we say their velocity of center of mass and their angular velocity, and we say omega is v center of mass over r, well, that works because it's rolling without slipping. And so that spot right here has the same velocity as the center of mass because it's rolling without slipping. Well, here, the block itself, the center of mass, has no angular velocity because it itself isn't spinning. So we can't use this for this problem because this block's center of mass is only translating forward. It isn't rotating. Now, particles of the wood are rotating, yes, but not the center of mass. So we can't use omega as v center of mass over r. So what we could do, and what a lot of us did, is we tracked the block rotating, found out 1 or half a rotation, divide it by time, and we get radians per second, which is like 75 or 76. Or you could have used conservation of linear momentum and solve for the velocity of center of mass of the block if that was an unknown that we wanted. But what we really wanted was the moment of inertia of the block. So this was calculatable, calculatable, calculatable. So all of that would allow us to solve for the moment of inertia of the block. So if the object is free to rotate and translate, then the velocity of center of mass, you can't do omega as v center of mass over r because the center of mass doesn't have any angular velocity. So my mistake on that, it would be conservation of linear momentum to get the velocity of center of mass, and then conservation of angular momentum to either solve for omega or solve for the moment of inertia of the block.